inside of the body, right? That you could put apply here. But this looks like it won't even take the apply. It will just output the identity. But let's try something. Let's do SND. And now we're gonna, let's try the, substitute the name, which is, so the function expression for the name of the of identity is lambda x.x, and apply. Let's see if we can do something now. Wait, let's put this also here. Kind of looks more sense. SND lambda x apply. Yeah. You might say now, okay, maybe I could do apply here instead of x, and SND apply. And then SND will give me apply. And then SND will give me, you know, apply, which would be wrong. SND should give identity. So what do we do? Yeah, it's interesting. Nothing. Nothing, right? What if we go other way around? We have identity and apply. Can we expand on apply? Would that help? No. So it's weird. It's like, what do you do? Let's see what he does here. Select first, identity apply. Right, that makes sense. Lambda first, lambda second, first identity apply. Right. Okay, he expanded the select first and just copied these two things here. Now identity, as we did, will go inside of the first. Inside, I mean, it will substitute the first and we remove the head of the first. So we are remaining with second identity apply. And basically, yeah, he just outputs the identity. So it looks like the second identity apply just discards here. It looks like he just discards it without even looking at it. It looks like select first simply discards without even looking at it. The second argument. Did I reconnect again? What's going on? Oh. Interesting. There was a network error again. Wow. Wait a second. What's going on? Linux OCaml. Why do I have OCaml? Oh, yeah. English. Yeah, there was some crazy lag. So I'm still on now, or this is just the stream is showing. Yeah. I guess I'm live. There was a network error. So if I just introducing stories. Wait a second. Channel. Stream. No, streaming tools. Yeah. Stream manager. Oh my, it's so slow. This CPU. Maybe it's this time of the day, right? It's like, you know, morning, and sometimes it will happen that internet here will just stop, you know. It will just stop and almost like restart. All right. So the select first function, which is a k combinator, indeed discards the second argument entirely. It doesn't look at it. Okay, these were my words. This is a core feature of how it works and why it's so powerful in its lambda calculus and computation theory. So the k combinator is defined as a lambda x, lambda yx when applied to two arguments, k ab, lambda x, lambda y, ab, step by step, ab, lambda x, lambda y, xa, lambda ya. Yes, that's what we did. So b never appears in the result, meaning b is completely ignored. Explicit discarding. By discarding the second argument, k explicitly expresses the concept of ignoring or erasing data. Okay. In functional programming, laziness is desirable property. Laziness. Since k doesn't use the second argument, it doesn't evaluate it, making it efficient when combined with lazy evaluation. Maybe this has to do also with lazy thinking, you know, like when you have a computation that you skip. Sometimes, yeah, you don't have to evaluate every branch, right? And choose the one that you want. But then the program doesn't work because one of the branches that you don't need doesn't evaluate. So with lazy evaluation, you can have like, let's say, two branches, and one of them will not terminate. But if you don't need it and you pick the second one, right, it works. The program works. Logical representation. Yeah, okay. Identity. Okay, well, that's kind of clear. This second identity apply. Then this could be A and B. So he's using the same things we had, but he didn't even look at the apply. So in general, applying select first two arbitrary arguments, argument 1 and argument 2, returns the first. Select first argument 1, argument 2. First, second, first, argument 1, argument 2. Second, argument 1, argument 2, argument 1. Right, that's what we had before. Now it's going to do with selecting the second of the two arguments. Consider the function. He's going to define select second. We already did that. First, second, second. This function has bound variable first. I guess what's also confusing a bit for me at first was that the select first, at the end you have the lambda second, which gives back the first. And you almost like expect it because the first and the second, right? So the second will give me back the second, but it's not. The second does the thing. It's almost like the second that it's supposed to take the second. It's not, the name is not, second because it takes the second. It's just, it's second, and what it does, it's return the first. It's like, I don't know if that makes sense, but it's kind of interesting. You have the first that does something and the second that returns the first. It's not like I'm the second and I'm going to do the second thing. I mean, I am going to do the second thing, which is going to be do the first thing. It's so weird if people would talk like that. Be ridiculous. It'd be ridiculous, right? We don't talk like that. Actually, we do, but it's kind of maybe more, with more words. I think with more words. Also, what I've seen that this kind of, when I do stuff like this, it really helps actually with talking even, because with the functions you can go inside of a certain kind of a thing and then talk about that, then go out of that thing and talk about that. Well, it's not so simple like this. I'm not trying to say it's like, oh, I do this and then I can, you get some kind of a power. No, but maybe you have time more time. It's like when, let's say, you're talking with someone, and you're not so bound with the first thing what you hear, but you can go inside of that thing. Okay, well, in this thing that we are talking about, we could have this or that. So in some sense, you're thinking of different kinds of things that you have in the thing that you're talking about, and then someone has a different idea, and then you can go inside of that idea without judgment. Let's say I have the first and the second thing, and someone says something else. That's my opinion. And then you could go, oh no, it's not like that. But then you can go inside of that thing. Well, okay, let's see that. So it's like you can always jump inside of something and find some kind of common ground. And in that sense, that's one of the reasons also why I like to do this. It's helpful, I think it's beneficial. I would put this. No, I mean, it's just very helpful. I mean, it would be nice if they would teach this in schools, because this kind of way of I don't know, I'm not sure if anybody wrote like that about that, but it has to do with how you communicate. So this way of going inside and outside, it's logical, actually. This is based on logic. So, and it's nice because it's not bound with anything what we are talking about. So in some sense, it's a way of how you go inside and outside of things, and maybe find some kind of symmetry in what you're talking about. I mean, yes, someone can say, oh, this is abstract, nonsense. Well, yes, but it's not nonsense. And it's almost like it's indirectly, it's, helping you when you communicate. So I've noticed it helps me, that's just my experience, when you talk with people about, but not about this, and then come back out and find an equivalence between, and or you don't have to actually find it, but it's like you get more time, so you're not bound with some kind of the need to get the result right now, right? It's not just, it's also about time. You get more time. So when you get more time, you get more patience and more calmer mind, So the comment you're saying, when you try to go into the second idea and then come back out and find equivalences between the two ideas. Yes, you could do that too, actually. Or you can go inside of the second idea and use what you know, right? How you compare things, and go into the second idea and try to find now equivalences in the second idea, right? Like what could be in the second idea. It's almost like you can talk, let's say someone is talking with you and they have a completely opposite stand than you. They have a completely different opinion than you. So you go inside of that. You find a common ground. Well, first you would need to find some common vocabulary. So before you engage with the idea, you find a common ground. So what do the words mean, right? What do our words mean? And then inside of that idea, you can look, okay, what kind of equivalences do I have in the second idea, in that idea? And well, I'm saying, I'm kind of describing this now, but in real life, I've just seen it that it helps me be more calm. So even if I talk with someone that will not talk like this, like at work, I work in a place that it's kind of, not so, I'm talking about work now, but it's kind of, okay, but toxic. But it really helps, when people, um, are really bound to what they think, and will even fight. So you can, at least, even if you cannot find agreement, I can look for it in my head. Okay, this is not working. Why? Okay, it could be because of this. It could be because of that. I can step out of that, I don't have to be, why is this happening? Why is this? Whoa, no. Okay, it's maybe because of this. It could be this. So it's, in some sense, this also what's going on here. It's helpful. Yeah, I don't know what. Now I'm kind of think I'm going round and round, but it's just, helpful. Yeah. This function has bound variable first and body. And also, as I said, it's not like there is some deep sense in this. I mean, yes, but it's helpful in a very indirect way. It's almost like you do, stretching. Well, as one of my friends who is like a really great, math guy, he said, math guy, he's a math, he's really great in math. He said, you do a bit of math, it really helps you, for your mind. Not in some kind of a deep thing, you do math and you will be, but it helps you, and when you deal with things, right? So just as math helps, when you deal with, things in life, also these things help, functional programming. And also because you start thinking in types. And we kind of do that, right? Because the expression itself, or what's going on, has a certain type. There was a study that found that mathematicians develop more gray matter in their brain than people who did things like art or cooking. Oh, interesting. Yeah, I'm not sure what that means, because there was a study also that people do, like I do music. I play guitar. So I did that my whole life. That's what I do. And I read also studies that people who do that, their brains also developed in all kinds of ways, because like I thought about, like, a lot of my upbringing was about sound, and everything what I do is about sound, and that also develops brain in some sense. And the study showed, yeah, I don't know, I'm not sure, but I'm not sure what's gray matter. I guess that's something good. Yeah, but it just helps, yeah. And math is, yeah, great. But it's not the way they teach math in schools. It would be nice now that they teach mathematical thinking. That's what I saw, and that was a great talk, actually. This is a nice talk. Wait a second, I'll try to find this before my CPU dies. Julie Moronoki, so she wrote a Haskell book, a really nice book. Haskell programming. Well, she and Chris Allen. And she has this talk, really nice talk. Julie Moronoki. It's a bit complicated, but gray matter is involved in the way we think, make calculations, solve problems, etc. Yeah. Julie Moronoki. And also, one of the things when you do math, it's like fine, you're kind of used to not knowing. It's almost like a different mindset. Like, I don't know, but I explore. So you're not so bound with what I know. Yeah, I don't know. I think this is called the power of metaphor, or something like that. Julie Moronoki, the unreasonable effectiveness of metaphor. And she showed a book here, actually. That's a nice, you can check this out, actually. I'll just put this in chat. She's nice. Chat seems active. What do you mean chat seems active? Chat paused due to scroll. She showed this book. Yeah, so she was saying like in schools they teach math, but they don't teach mathematical, thinking. So then she shows this book. What's the name of this book? The Irresistible.
Metaphor, the often dismissed metaphor. Okay, so we're gonna start off with a little exercise, and
so the name of this book is Which One Doesn't Belong? And this is a great math book. This is a math book, right? Anyone can, like, the moment you see this, it's not like solve this or solve that. Look at this. Which one doesn't belong? Like anyone can come to this and try to, solve this. And the entire book is like this. It teaches actually mathematical thinking through these pictures. Like the entire book is written like this. You have like on one page, you have certain shapes and which one doesn't belong. And you pick one thing that does not belong. I guess here you would take this because this is, I'd say that one that doesn't fit is the bottom left because, yeah. And the whole, you know what she did then? Look at this. Wait a second.
This is one of my children's books. I homeschool my kids, and this is one of the books that we have used for math. I thought my kids would be starting to outgrow this, but we still use it even though my kids are now 9 and 13. So this book is really to teach a lot of concepts, particularly in geometry, but it's more about teaching mathematical reasoning. So if we look at this page, and we ask ourselves which one of these 4 figures doesn't belong. The beauty of this book is that on every page, you could give an answer for any of the 4 figures that are on the page. So the goal is to make an argument, not to get the right answer. All right, so who wants to start off? Yes?
And then she will show with code. She will show...
The bottom right, because it has curved lines, and all the other ones just have straight, right?
Okay, wait a second.
Lateral.
Then she goes.
Triangle.
Wait.
Is which properties matter, right?
Yeah.
When we're talking about these, which properties of these figures matter? So there's a
great
context
book.
in which any of those properties might matter, right? If we look at this page, this is one of the first pages in the book, so it's one of the easy ones, right? There are some obvious ways that...
Isn't this a nice book?
For example, if our concern was color, we'd have a
You
very
almost
obvious
feel
grouping
it.
here, right? If our concern was size, we'd have another very obvious grouping, right? So the context matters to a certain extent for what properties matter for the analogies that we make. All right, now take a look at this one.
Check this out.
Which one of these doesn't belong?
What would you say now?
This is the same sort of exercise. Bottom left, okay? The list concatenation. Why does that one not belong? Okay. I will accept that.
Like, I'm not sure actually. I was not sure now when I saw this. There is a list concatenation. True, false, true. 4 times 3. 5 min 9. I don't know. Like, there is a computation going here. Or evaluation. 5 min 9 evaluation here. And true or false, true here also. And this, you could say that this is not. Yeah, because it's just concatenating. Or appending 2 lists. I don't know. I'd say that the bottom right doesn't belong because it's only Boolean. You see, but this reminds me of the IQ test when I was giving during my psychiatric examination. You see.
It's also not commutative. Very nice. Okay. So the list concat.
Not commutation, commutativity. I'm not sure. Yeah. Yeah.
Nation doesn't belong, but how about, are there any others we could pick out as not belonging here?
The bottom right.
Okay.
Is the value on the right is one of the values on the left. That's not true of any of the others.
Okay.
But that's also true of the left.
Oh, yeah, it is. It's the only one that doesn't work with numbers, right? Yes?
Oh, I think someone said, yeah, true, false, true is the only one that doesn't work with numbers. That's what you said. Yeah, it could be that too. I'm not sure. I think when I saw this the first time, I thought, yeah, either this or this. But I was at first confused because it was not so clear at first. So I was like, oh, well, okay, this is not so clear at first. So does that mean that our code is too complicated? It would be nice if we all see code like this and you just say, oh, this, that, you know?
Because depending on what kind of numbers they're looking at, it might only be symmetry of a model.
Right. So that you can make the argument that maybe this doesn't have any kind of sensible identity, right? Yep. Anyone want to pick the top right?
Top right. Top right is actually very simple, right? This is 5 min. Well, it's still an operator inside. This is the minimum operator that takes the smaller number from 2. And this operator combines the 2 into 1. Right? And outputs and, well, this actually reduces this value. This is something, okay, this something has to do now with what we are doing now, Lambda Calculus. This is, I think this is called, regex. Okay, this is really cool because you're not kind of, multiplying two numbers. You're reducing this expression with this one. You're reducing it. This is the value itself. This is the expression. I guess you could say this is also the expression, but it's reduced from here. So it's almost like you're not doing something. You're kind of reducing this to this level, to this most basic, like the base level. That's not the right term. 12. And 5 min 9, you're kind of not. You're comparing two things. Here you are adding two things, and true or false true, you are not reducing two things. On some sense, you could choose also this one. I'm not sure actually what will be the solution.
This one is maybe a little harder. All right. The top right, one of the things we could pick out for it not belonging is that it's the only one that's a product. It's the only one that's a conjunctive semigroup or monoid, right? The rest
It's the only one that's a product.
of these are various kinds of disjunction, right? Either
Okay, so these are all disjunctions, and this is a product.
choice or addition.
Choice
So-
or addition.
All right, so we can do the same thing here, right? We can look at this collection of data and decide that there are certain properties that we care about and certain properties we don't, and make
Also.
various analogies, right? Group
So you see what she's saying. She's not just saying, okay, that's the correct, that's not, but she looks at the properties of the data. So in that sense, when you talk with someone or even when you have a confrontation with someone, you look at the properties of what's going on, and that can give more calm. Even I'm not saying to be like, okay, I'm looking at the properties, I don't care. No, but it's like it can help to be more calm and see what's really going on,
them in different ways. On the other hand, in Haskell at least,
It's almost like you're not so bothered with the shape of the thing, but you start to look at the shape of the thing, and that can bring more calm. Okay, it's almost like there's a lion coming at me. Okay, what is the shape of the lion? It has long hair or short hair. Okay, let's stay calm. No, run. Okay, that was silly. So let's return to our, oh my god, this is going to be such a long series on Lambda Calculus. Select first, select second. Now we have a select second, and he's doing the same thing actually with identity and apply. First, so you expand the function name, he's being and I'm always like repeating the things because it's a good practice, right? It'd be so nice if we did this in school, you know, like the first, the second, the second, the first, yeah. The first, the second, and the second. Okay, the select second, it's expanded into the lambda first, lambda second, right? Now we have the two arguments that are being applied, the identity and the apply. But you see, it's even showed here, these are two arguments, but they are single arguments, right? There's a single argument applied to this thing, and there is a single argument applied to this entire thing. So you can see basically the curried form, which is kind of nice. Second, apply. Now it will choose the apply. Why it will choose the apply? Oh, why it will choose the apply? Right, if we let's do select second, identity, apply, and we expand first, second, right, and then identity, apply, and now we're going to substitute. Look at this, identity goes in the, wait a second, you see, I got stuck now again. Because look at what we had before. We had first, second, first, identity. Identity goes into first, right? This was kind of clear. Now identity goes into what? Because you almost think like I have to go to the outside first thing. Identity goes to the first. We have first, second. But you cannot just put apply here. Identity first. Well, maybe just identity drops. Because look, well, I think you could do it like that, right? So lambda second, apply. Because identity goes, and we remove the bound head. If we remove identity, identity goes inside of first, but there is no first. So that means bye-bye identity. It's almost like being mean to identity. Like, yes, identity, you can come in. I'm the first. Yes, of course you can come in. Thank you. Identity comes inside. Yes, I will leave now, and you can substitute inside for the first. Identity goes inside. It doesn't go inside. It just goes and it sees there are only seconds. There is no first. And then it drops. And the first, and then it's trying to find the first and tell him, where is the first? And the first is gone. So it's like there are only second here. Sorry. You're the first. We have no place for you. And the apply is outside. It's like, okay, hello. Oh, hello, apply. But you know what's cool? Apply is now here. And now we have the second and the second. And you could basically now rename this as first and first, because that's the alpha conversion. Now when you look at this, there is no difference between second and first and first. Here there was difference. But now you could basically rename this however you want. This is now basically just the identity function, right? If you remember the identity function, which was lambda x apply, right? That's the same thing, right? Right? It's the same thing. S and D or lambda x is the same thing. Apply. So that means second and apply. We get apply. Is that what he did? just now. What did I get? Select second identity, first, second, second identity. Now look, yes, it did happen. Identity went into first, and then, you know, they closed the doors to the identity. Identity couldn't get in. Only apply could get in. Identity, it would be nice, like you have a, you know, party of sorts and everyone comes in. I'm Halloween, I'm apply. What's your name? I'm identity. What's your name? I'm self-apply. Maybe that's not funny. Apply. Okay. Let's move on. The first argument identity was lost. Oh, it was lost. He couldn't get into the party. The first argument identity was lost because the bound variable first does not appear in the body. Second. In general, applying select second to arbitrary arguments, argument 1 and argument 2 returns the second argument. Select second, argument 1, 2. First, second, 1, 2, right? 1 substitutes for the first but has no place in the body. And then we have the body now, lambda second argument, and which is basically again just like our identity function. And in some sense, the identity that was lost, that couldn't get in, is extensionally equivalent to this expression, because this is also an identity and that's an identity. So in some sense, no one was lost. These are not concrete things. These are just descriptions of some relation. So you could say there's identity here again, you know? We were just kidding with you, identity. Please come in. So we can show that select second applied to anything returns a version. Oh, now he says that. We can show that select second applied to anything returns a version of identity. As before, we will use argument to stand for an arbitrary expression. So select second argument, lambda first, lambda second argument, second. Okay, if second is replaced by x, oh, that's what he's saying now. Okay, second becomes lambda xx. Yeah, that's what we were saying. It's the same as the identity function. Notice that select first applied to identity returns a version of select second. Select first applied to identity returns a version of select second. Select first identity, first identity, second identity. What do you mean a version of select second? Second identity, second lambda x dot x. If second is replaced by first and x by second, if second is replaced by first and x by second, then this becomes first, second, making pairs from both. Yeah, I think I've kind of lost him here. Notice that select first, I've lost him here. I'm literally lost him here. Interesting. It's almost like I can see what he's saying. I can see what he's saying, but it's just kind of, it's funny. It's like I can hear it. Let's check actually what chat will say. Chat is really great for these things when he just gives a little bit more, context. It really helps me. You are absolutely correct, and this observation is a beautiful example of the symmetry in relationship. Starting select first applied to identity, we begin with select first identity. Okay, lambda x, lambda yx, lambda xx. It's like I can hear myself. Is there? No, this thing is turned off. Psst, psst, psst. unstable. Encoding overload. Maybe that's why. Select first identity lambda x, lambda yx identity. Oh, he's select first applied to identity. Yeah, but it's, I guess one point you could think, does select first need to have two things? Like, select first needs to be applied to two things. And then select the first. But here it's being applied to just one thing. Even though that's the first thing. Substitute identity. Lambda x dot x for x in lambda x. Now he's substituting. Oh, he's substituting it. Wait. That's interesting, actually. You know what he's doing? So he's doing the select first identity. And he's gonna, but here is lambda x. Lambda x, well, we can use as before, lambda first, lambda second, first, and identity. So should we expand on identity as well? Yes, we should. Let's expand on identity as well. Lambda x. Well, we don't have to expand. We'll just get the second identity. Yeah, it's going to be the same thing. Because if we do this, we're just going to get lambda x dot x. No. We're just going to get lambda second. Lambda x dot x. That's all we're going to get, which is lambda x dot x, which is identity. It's just the second thing returns the first, but it's called the second. But what did he now? This, notice that select first applied to identity returns a version of select second. How is this a version of select second? Second. I'm not sure. How is this a version of select second? Right? Recognizing the result as a version of select second. The result is equivalent to a function that always returns the second argument. First, second, second. Why? What do you mean? This is exactly the select second function, also known as k prime. First, second, second, first, second. Swapping variable names. If you rename the variables in a way that better highlights the symmetry, replace second with first, x with second. You get first, second, second, which is select second. Oh. First, second, second. Second, first, second. You know what? I'm still kind of skipping this. If you rename the variables in a way that better highlights the symmetry, replace second with first. Replace second with first. Second with first. Does it mean this? Like if I replace it here with first, well, I mean, this could be, you know, I don't think he means this. Select first, first, second, first. Select second via identity, first, second, second. First, second, first. First, second, second. By applying identity to select first, you effectively flip the behavior, creating select second. You know, in some sense, the K combinator is a flip. There is a flip function also in Haskell. Like you have a pair and you can flip it. You have an AB and you flip it. I think flipping it is a combinator as well, because it has what it has, you know, and it flips what it has. In that sense, is a combinator. So this combinator picks out the first thing of the two, and the flipping combinator, I'm not sure what's the real name of it, what's the term, flips the two things. I still don't get it. I still don't get it. How is the first same as second? Simon. The first selector and the second selector aren't the same, but there is a specific relationship between them that can cause some confusion. How does select first? All right, we did this. First, second, first. It takes two arguments, returns the first one. That's clear. Identity function is lambda x.x. It takes one argument and returns it unchanged. Applying select first to the identity, right. Select first identity, got it. First, second, first, lambda x.x. Lambda x.x will go into the first, remove the head, we're going to get a second lambda x.x. Substitute lambda x for the first, right. We substitute, we get a lambda second x.x. The result is second x.x. Is that what they mean? The body lambda x.x is just the identity function. So this becomes second, which means second lambda x.x. This function takes second and always returns identity. Oh, but it's not. I thought it takes second. It's called second. But the second thing is it's weird. It's called second, but it takes the first. It's called second, but it takes the first. I see where the confusion is. The second selector is so named because it returns the second argument when two arguments are provided. The names first and second refer to which argument the function ultimately returns, not the order in which the arguments are taken. Oh. Why does select second take the first argument first? Every function takes exactly one argument at a time. Multi-argument functions are curried, meaning they take one argument and return another function that takes the next argument. Select second. Gosh, this is going on really. The function takes the first argument first and returns second. This is a new function waiting for the second argument. But it's just because we provided one thing. Okay, stop, wait. It's just that because we provided one argument and it takes the second, but where is the second? Yeah, I think I see now where the confusion truly lies. You are wondering where the second argument comes from when we haven't explicitly provided yet. Functions return functions, the key idea. Right. Every function takes only one argument at a time and may return another function. Select second. First, second. When you apply k prime to a single argument, first, second, a. K prime takes a as the first argument. The result is second. This is a new function waiting for the second argument. When you apply this return function to a second argument, b, well, then it will take b and b. Now the second argument b is explicitly provided and returned. No, he didn't. He's really good at explaining things, but now it's kind of going round and round. Yeah, I don't know. For me, it's not so clear. Notice that select first applied to identity returns a version of select second, because I'm not, sometimes you tend, like I could go too deep with it, and I go too deep and then I don't understand on that, level, and then I say I don't understand. That's also one of the problems, I think, when I try to learn this. Because on some level, like someone might say, okay, I get it. But it's almost like the need to understand more than what's available right now. And then you go deeper, and then you're like, okay, I don't get it. And you stop yourself there, right? While you could have just said, okay, I get it, second XX. Because, okay, actually, let's be more simple. Second, what did second apply? Select second, second, argument 2. Yes, but we are not applying. It's the interesting thing is that here we did give it 2 things. Select second applied. What's the select second if we just give it identity? Oh, now I see. Because select second, we give it only 1 thing. We didn't give it 2 things. If we gave it 2 things, okay. Gosh, this really took a while. So let's say I do select second identity, right? And that will be lambda first, lambda second. Let's do FST. Lambda second. Second. Identity. So yeah, select second. What did he do? We select second argument. First, second argument. An argument is being lost at first. Oh, he's talking about something completely else. He's talking about something completely else. Gotta go, my son woke up. Bye bye.